guys, are there any questions over the homework? Any of the homework assignment so far? All right. What we're doing today is starting 2.5, the last section of Chapter 2. And we're getting into some more formulas. We have the double angle formula, the product of sum formula, power reducing, and half angle. And depending on the setup, is going to depend on which one we use. So our first problem here, 2 cosine of x plus sine of 2x equals 0, is having us use the double angle formula, mainly because sine of 2x. And also, we need to get this in terms of sine or cosine so that we can solve. Now, our first step, our 2 cosine of x is not going to change. But our sine of 2x does have a theorem, because sine of 2x is equal to 2 sine of x cosine of x. So what that means for us is that we can replace sine of 2x with 2 sine of x cosine of x is equal to 0. Because we're trying to be able to solve, get this to either have something in common with both terms or some way to simplify down. And when we rewrite in our cosine of x, it gives us a greatest common factor between these two terms, our 2 and our cosine of x. And since it has it in common in both terms, we can factor this out. Because if we factor the 2 cosine of x out of 2 cosine of x, we're left with 1. Plus, the 2 factors out, leaving us with just sine of x is equal to 0. Questions on this so far? Now at this point here, we do have 2 things multiplied together to equal 0. So one of these, either 2 cosine of x is equal to 0, or our 1 plus sine of x is equal to 0. One of these 2 has to equal 0. Now for our 2 cosine of x, well, we can divide both sides by 2, telling us cosine of x is equal to 0. With our sine of x, we can subtract 1 from both sides, telling us sine of x is equal to -1. Questions on this here before we find our angles? Now at this point here, we can find our angles, our values of x. Well, cosine of x equals 0, and we can look at the unit circle at pi over 2 or 3 pi over 2. And sine of x equals -1 at 3 pi over 2. Now it did not tell us that our angle is restricted from 0 to 2 pi, so that means we have to add the 2 pi in back in to include every coterminal angle. So these here are our 3 answers. Well, technically 2, because the 3 pi over 2 is repeated in both, so we just need to list it once. But that's it. Questions on this here? All right. Let's look at the next one. Cosine of 2x plus cosine of x is equal to 0. Now the first thing we really need to do is change this cosine of 2x to just cosine of x. Now cosine of 2x is equal to cosine squared of x minus sine squared of x. Cosine of 2x is also equal to 1 minus 2 sine squared of x. And cosine of 2x is also equal to cosine squared of x minus 1. Sure. almost, I forgot the 2. 2 cosine squared. We have these 3 different equations for cosine of 2x that we can use. Now the one we want to use is probably going to be the one that helps us keep this in terms of cosine. Now if one of them had sine, if it had been cosine of 2x, and this instead of cosine had been sine, we might want to use the middle one because it would get us in terms of sine. Everything's in terms of sine of x. Or if we did have a sine of x and cosine of x, we might use the first one. But because our other term is cosine of x, we're going to want to use the bottom one, our 2 cosine squared of x minus 1 is going to take the place of cosine of 2x. Plus cosine of x is equal to 0. Now we can get this in standard form. Our 2 cosine squared of x plus cosine of x minus 1 is equal to 0. Now, unfortunately, this one here, there's not a greatest common factor, so we can't factor a term out to simplify it. But this is factorable. So we'll have our 2 sets of parentheses with 3 spaces. Since the third term is positive, or if the third term was positive, the signs are the same and match the sign of the middle term. But since the third term is negative, our signs are going to be opposite. Now our factors of cosine squared is going to be cosine and cosine. Our factors of 2 are going to be 1 and 2, and we just need to place the 2 in one of our 2 spots. Factors of the third term is 1, so we have 1 and 1. Now we do need to check and make sure we have the correct middle term. We might need to change something here because 2 cosine of x times negative 1 is negative 2 cosine of x. 1 times cosine of x is going to be plus cosine of x, telling us that we have negative cosine of x, but we wanted positive. So anytime we have the correct number but wrong sign, we just need to change the signs. Because now we'll have positive 2 cosine of x minus cosine of x is equal to positive cosine of x, which is what we wanted. And we have 2 things multiplied together to equal 0, so one of these has to be 0. So we're going to set both of them equal to 0 and then solve. Now for the one on the left, the first thing we can do is add 1 to both sides, telling us that 2 cosine of x is equal to 1. Next thing we can do is divide both sides by 2, telling us cosine of x is equal to 1/2. Our other equation, we can minus 1 from both sides, telling us cosine of x is equal to negative 1. Questions on how we got to this part here? Now to find cosine of x equals 1/2, well, we can use the unit circle and see where the x value is 1/2 on the unit circle. Well, we're looking at pi over 3 and 5 pi over 3. And then cosine of x equals negative 1 at pi. Questions on any of this here so far? Now again, they didn't tell us the interval that it's on, so that means we have to come back in and add 2 pi in, so that we consist of every possible angle that will make this statement true. And that's it. Questions on any of this here so far? We ready for the next part? Find all the double angles from the given information. So they tell us two things. One, that cosine of theta is equal to 5/13, and theta is between 3 pi over 2 and 2 pi. So if we're to draw this, well, 2 pi, 3 pi over 2 is just telling us that we're in the fourth quadrant. And this is going to be our angle here. Now, out of these three here, we can find cosine without having to do anything else. Because cosine of 2 theta is equal to 2 cosine squared of theta minus 1. Because that's one of our three forms. And since we already know that cosine is 5/13, we can say that this is 2 times 5/13 squared minus 1. Because we already know the value of cotangent, or not cotangent, cosine. We can plug this in. Now, exactly, we could actually say 2 parentheses 5/13 close parentheses squared minus 1 is negative 119 over 169. And that's our value of cosine of 2 theta. Sine of 2 theta. This is just straight from the definition. Sine of 2 theta is equal to 2 sine of theta cosine theta. Straight from our formulas. And if we look at this here, 2, I don't have sine of theta yet, but we know that cosine of theta is 5/13. So if we can find the value of sine, we can get our angle for sine of 2 theta, or get the value of sine of 2 theta. Well, now we'll need to set this triangle up. Cosine, adjacent over the hypotenuse. So adjacent, our x is 5, hypotenuse is 13. We need to solve for the other side. And to do that, well, let's scroll down. We're going to have 5 squared plus b squared is equal to 13 squared. And we can solve for b. Now 5 squared is 25 plus b squared is equal to, well, 13 squared is 169. At this point here, we can subtract 25 from both sides. Telling us b squared is 144. And the square root of 144 is, we would say, plus or minus 12. And since we're in the fourth quadrant, our y value is actually negative because we're in the negative quadrant. Questions on this here? So that tells us sine is opposite, so the opposite side would be our negative 12 over 13. So in the calculator, we're going to do 2 times negative 12 over 13 times 5/13 is negative 120 over negative 169. Questions on any of this here so far? Now the last one's tangent. And if we go by the theorem, it says that this is 2 tangent of theta over 1 minus tangent squared of theta. Now tangent is opposite over adjacent, so it'd be negative 12 over 5 over 1 minus negative 12 over 5 squared. And again, we could plug this in. Fraction 2, negative 12 over 5 over 1 minus negative 12 over 5 squared is 120 over 119. Yes. Yes. So really for this here, we just need to set the triangle up so we know this opposite, adjacent, and hypotenuse, and we can find our values here. Questions on any of this so far? Now, tangent, there's another way we could have done this. Tangent is sine over cosine. There you go. 120 over 169 over negative 119 over 169, which gives us 120 over 119. So either way, we can get to the same answer. It's just figuring out which way we want to go, especially with tangent, because tangent is just sine over cosine. Questions on this here so far? We're going to look at another one. Find all the double angles. Given that sine is equal to 3/5, and our angle is between 0 and pi over 2. So we're in the first quadrant. And if we set this triangle up, sine is opposite over the hypotenuse, and the adjacent side would be 4, because it's a 3, 4, 5 right triangle. Now, unfortunately, unlike with the last one, we can't just have gotten sine of 2 theta like we did cosine. Because we can replace sine of theta with its value 3/5, but we still need cosine of theta to actually get the angle. Cosine is going to be adjacent over the hypotenuse. Adjacent side is 4. Hypotenuse is 5 based off that triangle. And again, just like before, we can plug this in. And we get that sine of 2 theta is 24 over 25. 24 25ths. Questions on this here? Now, there are several different versions of cosine of 2 theta that we have. Which one do y'all want to use? Because it really doesn't matter. I'll have y'all pick one, because there's 3 of them. So double angle. Because we have cosine squared minus sine squared. 2 cosine squared minus 1, and 1 minus 2 sine squared. Yeah. Cosine squared of theta minus 1. Now cosine squared would be 4/5 squared minus 1. And again, we can bring up the calculator. 2 times 4/5 squared minus 1. And the cosine is 3/5. And it tells us it is 7/25. Now the other one was sine squared, so 3/5 squared. No, sorry, cosine came first for the other formula. 4/5 squared minus 3/5 squared, and we get 7/25. The other one was on minus 2 sine 3/5 squared, and what do you think we're going to get? 7/25. Because no matter which one we pick, it will give us the same answer. It's just going to depend on what we have. Like the last one, we already had cosine to start with, so we can use 2 cosine of theta squared minus 1. We already have cosine, we plug it in, we're done. Here, since we already have sine and cosine, it didn't matter. We just had to pick one. Tangent. Well, tangent, even though it is 2 theta, is still sine over cosine. Which if we plug that in, we get 24/7, and we're done. Because we can use the tangent of 2 theta theorem to get that 2 tangent squared over, or 2 tangent over 1 minus tangent squared. It will still give us 24/7. It just, for these here, so, let me see. Yeah, because here also, if we look at each one of them, because it's sine of 2x, or sine of 2 theta, cosine of 2 theta, tangent 2 theta, it's double angle, we're multiplying it by 2. If it was theta over 2, we'd use half angle theorems. And here is double angle also. We had to use it because of cosine of 2x. We needed it in terms of x for us to be able to solve. Because, and it seems odd why we need that, because cosine of x, we can actually work together with these two here. Cosine of 2x and cosine of x are not like, terms are not the same. So they operate differently. Because if we said x is 45, well, this would indeed be cosine of 45. This would actually be taking cosine of 90. So we have different values for how those two work. Does that kind of make sense? All right. Sine of 3x. We want to rewrite this in terms of sine. I did add sine in because your note sheets doesn't have sine of x. This piece here, I went back, I printed them, and then realized that it needed to be changed to just sine of x. So to do this, this is a little weird. What we're going to have to do, we're going to rewrite 3x as 2x plus x. 2x plus x, because what we're trying to do is get that number inside there to be just x. We just want sine of x. Doesn't matter if we have more than one of them, we just need sine of x. And unfortunately, if it had been, say, 4x, well, we could do 2 times 2x and work with double angles and double angles all the way out. But here, we have a sum, which would be sine of 2x, cosine of x, plus cosine of 2x, sine of x. So this is our sum identity that we're using first. Now, we're getting closer because now we only have two expressions where we don't just have x inside the parentheses. Now, for our sine of 2x, we can use the double angle formula. Which means we can replace sine of 2x with 2 sine of x cosine of x. Which is nice because now each of those trig terms only has x inside the parentheses, so we're getting closer. Plus sine of x times, we need to replace cosine of 2x. We have three different options we can choose from. Now, this problem asks us to get this all in terms of sine, yes? Well, not going to be using the middle one because that's gets it all in terms of cosine, not in terms of sine. We're a little farther away from where we want. First one's not bad, but we do end up with a cosine squared. And the third one does get all of cosine out for that one there. Questions on that there? All right. Now the first expression, first part of this, we can multiply this out, which will tell us that we have 2 sine of x cosine squared of x plus, here we can distribute the sine of x. Sine of x times 1 is sine of x. Sine of x times negative 2 sine squared is going to be negative 2 sine cubed of x. So we almost have it all in terms of sine. We just have that cosine squared, yes? According to the Pythagorean identity, cosine squared of x is equal to 1 minus sine squared of x. So we can replace that cosine squared with 1 minus sine squared of x plus sine of x minus 2 sine cubed of x. Now, luckily enough, we're almost done. We just have to distribute this through and then combine like terms. 2 sine of x times 1 is, well, 2 sine of x. 2 sine of x times negative sine squared is going to be negative 2 sine cubed of x plus sine of x minus 2 sine cubed of x. And luckily enough, this is not 0. Probably in Algebra 2, Algebra 1 geometry, it was nice when everything canceled out and became 0. I think we're to the point, this is so much work. We're doing so much stuff that if everything canceled out and became 0, we'd almost be more frustrated than we were in previous classes. But luckily enough for us, make sure, yep. Yep. 2 sine of x plus sine of x are like terms, negative 2 sine cubed, negative 2 sine cubes. Now we are going to put the sine cubed first for one main reason and one main reason only. It has the bigger exponent, so it has to go first. So our negative 2 minus 2 is negative 4 sine cubed. 2 sine of x plus sine of x is 3 sine of x. And that's it. So this here is just a lot of manipulating to get what we want. We'll finish this later.